Hello, everyone, and welcome. My name is Joe Fontaine, and I lead the AI school at Udacity. For the last 18 months, there's been a lot of noise, a lot of uncertainty for software engineering and how AI might be changing that role. The craft has always been about mastering explicit deterministic logic. But now you see tools that are getting very good at writing that logic for you. And it's valid to look at that and wonder, what does my role look like in 5 years? Well, it's evolving, and it's evolving faster than any of our roles ever have, right? The job description is being rewritten in real time. The question is, who's holding the pen? From where I sit, it's not an extinction moment, it's a massive expansion moment. The moment your roles evolve from writing code to orchestrating intelligence. It turns out that the skills you spent a decade mastering, systems designs, debugging complex logic, obsessing over performance, securing infrastructure, those aren't obsolete. They're the precise foundation required to build a new generation of AI systems. And that's what we're going to talk about today. We're going to talk about how you take the pen and write the new job description for yourself. I'm super thrilled to be joined by two people who are doing exactly that. They're both expert authors who have helped build some of our most popular and advanced new AI curriculum. First, we have Enrique Santana. We're fortunate to have his expertise as one of the lead authors on both our Agentic AI curriculum and the new LangChain program. He brings an incredible 360-degree view from his work in enterprise and as a professor. Enrique, it's so great to have you. To get us started, could you tell us about your day job as a principal machine learning engineer at Dell?
Sure, Joe. Thank you. Yeah, at Dell, I sit in a very unique place between engineering, MLOps, and product. I lead a work stream that helps our marketing and sales organization apply AI responsibly at enterprise scale. That means everything from designing data and model pipelines to architect and design agentic systems to building the operational layer, monitoring, governance, cost controls, deployment. We work in two fronts, like supporting data scientists. This is the role of MLOps in general, like infrastructure to train, deploy, and monitor models, and building agent-based systems. Like how to automate and how to use like LangGraph and LangChain. So my job blends systems design, reliability, engineering. The point is how we can create this production environment with strict compliance, SLAs, and scale. I think it's something like that.
That's super interesting. And it sounds like you cover quite a bit of ground across the production life cycle for that. It's a great window into the enterprise scale of the modern ML engineer. Thanks for sharing. Excited to dig in more about your role as we get later into the show. And we also have Gerald Parker. Gerald's journey is one I think many of you probably know and will connect with. He's also one of our lead authors on our new Agentic AI engineer with LangChain and LangGraph nano degree. And he's a perfect example of the evolution of the modern software engineer and the AI engineer. Gerald, welcome. Can you tell us a little bit about your work as an AI engineer at Brevity Pitch?
Sure. Thanks for having me. So at Brevity Pitch, I am kind of operating as a software architect and AI engineer. As a company, we're focused on building basically voice-to-voice sales rep practice agents. So if you are part of an organization that has, sales reps like many companies do, it's often it's popular where those sales reps may need to practice selling to customers, handling objections, making sure they hit on all their sales points. And so we're building a voice-to-voice agent that allows people to or teams to kind of upload, okay, what are the products, what are the requirements? Tell this agent about your company, about your target customer, and then your reps can practice against that. So some of the things that Enrique hit on, building out the frameworks, building, handling scalability, sure that things are reliable, handling unpredictability, and so that's all a part of the job.
I love a good agent for agents. So an agent for sales agents and multiple modalities working in speech to text and text back to speech. Super interesting. Excited to dig in more to that. So today we're going to explore both of your unique paths, the hard-won lessons that you've learned along the way, and how our audiences can architect their own evolution. So with that, let's get right into our first topic. Now that we know what you both do, let's dig into those roles. ML engineer, AI engineer, they get thrown around a lot. There's an increasing overlap in what it means. Enrique, starting with you, you've seen this field from the data science, data engineering, and the ML ops side. How do you define your role as a principal ML engineer? And where does the data scientist stop and the ML engineer begin?
Yeah, good question. Because I started as a data scientist and now I'm ML engineer. So, I see the transition. What I like to say is that I see data science as exploring ideas, like understanding the business problem, building a model, validating hypotheses, communicating, insights in the end of the day. And
Mm-hmm.
ML engineering, ML engineers, they need to be in the beginning of this process, of course. But, where they really shine is, after the notebook. Because all this experimentation, of course, it's really important, but we need to make sure how we can move to this enterprise scale, at least in my position right now. So the problem is no longer does the model work. It's more like how do we ship this reliably? How do we monitor drift, for example? Not because the model is working right now, it will continue working. Imagine like we have the pandemics, customer behaviors change, for example. How do we version the data sets data scientists are using to build those models? And how do we integrate with infrastructure, API, CI/CD, access control, compliance? Data scientists, they build the logic and
Mm-hmm.
ML engineers build the system around the logic so the business can trust it every day at scale.
Yeah, I think that's so critical, right? There's a lot of opportunities to build really novel solutions with AI these days and to develop really interesting models. I think the accessibility of doing so with the evolution of tools recently has made that
Yeah.
increasingly easy. We're seeing that iteration happening really quickly, but at enterprise scale, deployment, monitoring, and governance, without that, you can't get it off the ground, right? Or it just becomes a liability. So how much of that, in your role is a focus of, maintaining these systems and making sure that they can hold up to the constraints of the enterprise?
Yeah, when you talk about like a organization, this big, we are talking about one piece inside the bigger picture. If
Mhm.
you take only my organization under marketing, we are like 100 of data scientists and engineers. So, for one piece of marketing, so there are a lot of people working here. So we need to make sure that we can take all the data that are available and have this streamlined pipeline so we can like we spot data quality before like reaching to our customer. So if you're
Mhm.
like sending a kind of communication to them, like we cannot reach them by an email or a seller talking to a client saying, hey, I know that you bought these and these servers, and say, oh my God, I never bought server from you. So this is
Mhm.
the kind of thing that we need to deal with. We have data from, you know, different kind of products in different kind of regions. If you see like doing marketing for Brazil is different from China and doing marketing to US, for example. So we need to,
Mhm.
to make sure that we have data scientists and data scopes, domains for different parts. And if you are with me here, you can understand that even AI and ML, and I keep talking about data, because this is the foundation for everything we do in the end of the day.
Mhm. You make such a good point there, right? Without the reliability of that data, you in your role particularly, it sounds like could burn customer trust, and once that trust is lost, it's really hard to win back, right? So it's so critical that we're not just providing information; we're providing the right information reliably, consistently, and at scale, right? Gerald, I think your path is so relevant here. You're a back-end architect. Now your title is AI engineer. When you're building agents at Brevity Pitch, how much of your brain is in back end architect mode, thinking about the APIs, the state and reliability, versus new AI mode?
Yeah, I mean, honestly, a lot of it is still kind of in the back end architecture mode. I feel like It's taking kind of like the new frameworks, the new kind of tech stack that has been kind of evolving over the past few years, and really kind of embedding that into the existing patterns and uh, practices that we've already been using. Like at its core, backend architecture still focuses on interfaces, on state management, concurrency,
Mhm.
um, error handling, reliability, and these become these are just even more crucial when we're building AI agents, right?
Mhm.
Think about like kind of like a GPS system. It's one thing to be able to design a system that tells you to turn left or right. It's another thing to be able to say, okay, well, what happens when somebody turns the wrong way, right? And so
Mhm.
it's building those systems within these existing design patterns. And so, yeah, I think like a lot of people have maybe fallen into the trap of thinking like, oh, we're just throwing everything out the window. This is an entirely new way of operating, but a lot
Mhm.
of it is still the same, just with the new kind of tech stack and kind of this probabilistic model.
Yeah. And these days, it's not even just if someone takes the wrong turn, right? If it's some model takes the wrong turn, how are you self-correcting, right? So you mentioned the tech stack sort of evolving. Let's talk a little bit more about that. What's the transferable knowledge from those components, of your more traditional software engineering, and how are those components evolving with LLMs, vector databases, the frameworks that you're working with? Uh, yeah.
Sure. So, yeah, I mean, in terms of transferable knowledge, I think like there's still, I mean, when we talk about, the advantages of perhaps maybe like microservices to monoliths, right?
Mhm.
We normally there's kind of an evolution. You start out small, and then once you hit this need, you're kind of thinking like, okay, we're going to evolve this into microservices. And I think that that same approach of like start small and build on top of it, that absolutely applies to when you're building agents, and that
Mhm.
kind of applies for like all areas of the tech stack. Let's not like over optimize. Let's start out solving this problem. Let's implement it. Let's make sure we add logging, all of the basics that are necessary to capture errors when things go wrong, and adjust to ensure that they don't happen again. From like a new technology point of view, there's no question. And we talked about vector databases. That's something that is getting used more frequently. Not that it wasn't a thing before. I mean, Elasticsearch was very popular before this. But
Mhm.
then we also talk about integrating with observability platforms like Langsmith, right? So that's kind of a new piece of technology where it gives us greater insight into understanding, exactly what the agent is doing, what are the paths that it took, how much does it cost, and so there's certainly a new set of metrics that are important for kind of monitoring, and I'd say that's probably the biggest changes. I mean, aside from the frameworks, it's like what are the new things that we need to be looking out for?
Certainly, in terms of AI systems management, observability, if you can't understand or define why your agent is taking action, it's by definition not reliable for you, right? So, how do you move it into production with that much risk? I think it's really interesting how both your roles are increasingly touching on the concept of agentic AI, which you're both clearly deeply involved in. Gerald, in the LangChain course you built, you lay the foundation for that. For a developer who's only ever written static logic, what is an agentic system? What's the core technical difference that makes it a distinction from just calling an API?
Yeah, so I mean, when you're calling an API, that's a very kind of like linear workflow, right? Like you make
Mhm.
a request, as long as you make the right request, you know what you're going to get back. Even if you make the wrong request, like you pretty much
Mhm.
should know, like, all right, I'm going to get back, 404, 400, whatever the case is.
Mhm.
And so when we're operating within this agentic framework, we're essentially giving the agent greater control over the system, right? And not only that, where purpose of this is often like, we're using human language in order to provide input to that system, and so
Mhm.
uh, we're giving the agent control over, how should I respond to this? What are the various options that I should evaluate? What things of this input should I focus on, right? And so that's super kind of unique and huge differentiator from the kind of the standard API request model.
Mhm.
And then in addition to that, we're adding things like, tool use, memory to the agent or state
Right.
management, reflection, the ability for the agent to kind of self-correct or self-critique itself.
Mhm.
And so those are kind of like the things I say separate um, kind of an agent operating from the framework from a standard API call is you're giving it much more autonomy and control over the
Mhm.
execution flow of that program.
Absolutely. I think, with the traditional API call, the logic is deterministic and completely defined, right? And what separates your agentic systems is giving it the context for the task, the ability to act on that by giving it access to the tools, right? So that it can execute that. Enrique, any thoughts from your end on
Yeah,
the key differentiators there?
yeah, I completely agree. I think when we transition
Oh, I
from
think you're
regular,
muted. There you go.
is still muted.
Nope, you're good.
Okay. Um, I completely agree. When we transition from regular API calls to like agents, we need to make sure that we have things under control. Like
Mhm.
we need to filter the inputs and also the outputs of these agents. Um,
Mhm.
in our case, imagine that an agent, for example, decides because of the plan it created that because an account has not been buying from us recently, we need to delete all the records, and you
Mhm.
give freedom to this agent to do that, so we need to have some boundaries for this agent. So I completely agree with Jared on this part.
Yeah, fantastic. That's a great technical definition, and I want to unpack that. But first, I do want to address the audience and say thank you so much for all the questions that came in prior to the start of the webinar, and keep them coming as we go. We are going to be answering during a Q&A session in the last 15 minutes. So sit tight, and if you have specific questions for our two guests, keep them coming. We'd love to hear them. So we are hearing agentic AI everywhere. Some are calling it the next decade of AI, if you believe Andrej Karpathy there. I'd love your take on this, starting with you, Enrique. Is agentic AI engineer becoming a distinct specialization role that you're seeing in the market?
Yeah, if Andrew says that, who am I to disagree? But I don't like the terminology, like calling someone like agentic AI engineer. I think it's too much.
Mm-hmm.
And I don't know. How can I say that? If you're a developer, you're a developer. You're not a JavaScript developer or I know C#.NET developer. You're a developer that this time we are working with this piece of technology or this language or this framework.
Mm-hmm.
I don't like because we're calling like agentic AI super recently. Like we have agents for decades now. If you
Mm-hmm.
take the um, uh, artificial intelligence modern approach, the canonical book, it starts with agents, so it's
Yeah.
an old concept, but the abstraction that we are calling agents on top of LMs, it's fairly new.
Mm-hmm.
And so yeah, I think we are all AI engineers in general,
Mm-hmm.
but at this time we were specialized in building AI agents, let's say. So but
Mm-hmm.
yeah, because of hype and all the craziness we are facing these days, I agree that we are seeing more and more like these specialized like context AI context engineer, RAG engineers, agentic AI engineers. So I agree we can see that, but I don't know if it will stand the test of time.
Yeah, I think that's a really valid point. And to your point of agent being sort of a foundational component of AI long before the advent of agentic AI, if you will, that was one of my first introductions to AI, working on reinforcement learning with Deep Racer that you see behind me, and working with
Yes.
agents in that virtual environment to train the model. So I think your point's 100% valid, and I'm really glad you brought it up. If you look on search boards today, you're not going to see 10,000 agentic AI engineer titles, right? It hasn't become this standardized role. But I do think what's really interesting is skills data. And so using a definition of agentic AI engineer isn't so much about putting someone in a box and saying, that's your role, that's the scope of what you do, but it's the velocity of what the required skills are. And so if we look at some of the recent data from DICE and Lightcast, we can see that AI agents is a skill that's grown 2,000% year over year. And the demand for frameworks like LangChain is exploding. So I don't think it's unfair to say,
Yes.
you should be a LangChain agentic AI engineer, or you should be an agentic AI engineer in that way.
I agree. I agree. But most of my data scientists these days, they are building agents. We created this framework, to intercommunicate with LangGraph, for example,
Hmm.
and they're building agents, and that's the democratization part of the technology. So
Yeah.
we are they are still data scientists, some are data analysts and ML engineers, but they are all building some kind of agents for automation of their work. But yeah,
Hmm.
I agree with you if this goes.
I think it's a really interesting one because it hits on both sides, and this is sort of the crux of the conversation we're having too, right? As an AI engineer, and in most engineering roles today, you need to be both fluent in using AI tools, and in this case, agents, as well as in many cases constructing them. So while you may not be a exclusively an agentic AI engineer specialist, most roles will need that. However, there's still a lot of really valid use cases that aren't agentic, right? And I think if we look at, the AI engineer who's building a CV model, a computer vision model for factory defect detection, you don't want, uh, you know, a generative model necessarily solving that. You need it doing vastly different work than someone who's building a multi-agent system with LangGraph that's researching and writing a report, right? So I think there's still so much breadth in the AI engineering roles and the various specializations that there's sort of a room for all types, if you will. My
Yeah,
question to you is:
agree.
Do you see a fracture coming there? Will AI engineers split into more specializations in the way we saw software engineer, or fracture into back end, front end, DevOps, even further than we are today?
Yeah, I think we are in the infancy of these kind of careers,
Hmm.
and even now it's hard to differentiate my role from Jared's, for example, because I was hired as data engineer, then I transitioned to ML engineer, and
Hmm.
now what I'm doing is like creating the foundations so everyone in the organization is able to create their own agents,
Hmm.
so how they can create agents, how they can create like MCP servers really
Hmm.
fast, so they don't need to mine. So it's more like the infrastructure and the foundations for them.
Sure.
But in the end of the day, my data scientists, they are creating MCP servers, they are creating
Hmm.
agents. And yeah, we are in this era. I don't know, 2 years from now, if the role needs to change, because they are not only creating the models, the machine learning models, but the models that interact with the ecosystem. It generates data, and this data need to
Yeah.
be available. And we need some kind of agent that can read this data. So
Hmm.
and even for MCP, like this model context protocol, I can see that it's another part. Like if you build an API, you need to create a documentation. I think
Hmm.
like you create your work, and then you have like this kind of documentation that is exposing this or creating some kind of automation, so the others can fetch your data, interact with your model. So
Hmm.
that's how I see.
Absolutely. I think now more than ever, we hear about the power of AI 10xing, 100xing a good engineer and needing to be fluent in those tools to be able to do it. Also, what you're describing, both at the technical level, your data scientists being able to take that process a lot further than they did 5 years ago with the tool accessibility. We also have business professionals who are able to self-serve with these low-code, no-code agent tools. As a final thought, Gerald, what is, Henrique just mentioned a lot of the crossover and how those roles are evolving. What is the set of skills that every engineer will be expected to have? Or where do you see some more fracturing and deep specialization? What is that like? You have to have this in your toolkit if you want to continue to engineer into the future.
Yeah, so I do think choosing purely between a back end and front end engineer, I think that option will start to diminish. I mean, I think it already has. Yeah, I've spoken with people and been in interviews where, you know, even though maybe a back end role, they're asking about front end experience, and that's especially with these AI coding tools. That's just kind of the expectation, and not
Hmm.
just because you've got coding agents to help you implement it, but also
Hmm.
the availability of tools to learn from, right? And so
Hmm.
like you're just kind of expected to pick up that knowledge, and that's always kind of been true to some degree in software engineering, that it's you're always going to be expected to kind of continuously learn. And so, I mean, I think in terms of like the skills that are still relevant. I mean, I kind of mentioned some of those earlier, being able to look at problems, break them down into small pieces, being
Mhm.
able to kind of understand how you can apply existing algorithms and patterns. And so, um, and it kind of it turns out that having that understanding of architecture and design patterns in general actually is kind of the best way to instruct some of these coding agents to do its work. And so I think that will certainly always have a place. I think the question you guys touched on about specialization,
Mhm.
I think that's really interesting. I tend to think that over time there will be kind of deeper specialization within AI because
Mhm.
I think some of the considerations for building reliable, voice to voice agents,
Mhm.
it's going to be different than, when, robotics is kind of starting to take off now. It's a different set of skills. And so,
Mhm.
and I think people will want to label kind of themselves and say, this is the area where I've kind of gained deep knowledge and experience for companies looking to develop those types of applications.
It's such a great point, right? The application of AI is so varied and robust that there's a lot of room to specialize both in verticals, like you mentioned, whether that is, modalities or whether you're in manufacturing or finance or healthcare, what have you, as well as ecosystems, right? There's a lot of different clouds on-prem, multi-cloud systems that you can specialize in that are explicit to a certain enterprise. My question for you is, when we look at some of those agentic advanced skills, planning, tool use, autonomous reasoning, do you think that's going to start to become a standard part of every AI and ML engineer toolkit? Or is that something that everybody's just got to master today uh, and be able to leverage in the future?
Yeah, I think it's going to be a kind of a required part. I mean that just kind of comes along with the piece of giving agents greater autonomy. I think you have to understand um, how do you give it the tools and the means to do its job? How do you how do you kind of implement different layers of abstraction so that you can have kind of supervisor agents and kind of worker agents to which the supervisor delegates tasks. And so I
Mhm.
think just having a general understanding of kind of the frameworks, the tools, the patterns within that are going to be required regardless of whatever role you're in. I mean, that's kind
Absolutely.
of the definition of what it means to be an agent. Yeah.
Yeah, it comes back to that explainability and observability that Henrique mentioned before, right? If you can't contextualize what's happening with that agent, you can't confidently move it into production. So whether you are, applying it to every single project you're working on, you still need to, I think, have that fundamental skill set in order to continue to contribute. Excellent. So I'm going to pivot us a little bit. We've defined your roles. We've framed up the agentic skill set a bit. Now let's talk about the work. This is what gets me the most excited. It's moving those proof of concepts into production. So, Gerald, at Brevity Pitch, you're building practice agents for your sales teams. It sounds exactly like the agentic patterns, the planning, the tool use, and memory that you teach in the new LangGraph course. Can you connect the dots for us and how your job is moving beyond the initial wow demo and into the hard production challenges?
Sure. Yeah. So one of the first things we're kind of trying to look at doing is how do we break these things down into kind of more modular components, right?
Mm-hmm.
And I kind of talked about the idea of microservices earlier, and so that's kind of the
Mm-hmm.
approach that we're taking is okay, we've got a agent or a service whose job is it to take in this initial information,
Mm-hmm.
kind of contextualize it, perform deep research about this company, about the information, everything that they give us, and distribute it to other services on the platform. Also,
Mm-hmm.
that often contain agents, so that they can do their individual job. So we're saying like we've got this practice agent. Well, this agent that they're actually going to practice who maybe needs information from this deep research service agent that has
Mm-hmm.
contextualized and gathered this information. And so that's kind of been a huge focus is like, how do we break these things down? Similar, I mean, I guess you kind of could think of it the way that the like a human brain works. And there is kind of like a concept, we hear this term AGI, getting thrown around artificial general intelligence. And I think like there's a theory that the way that we get there is not by any single model, right? It's all of
Hmm.
these individual models specialized in different things that work together, right? And that's kind of
Hmm.
the approach that we've taken. And so aside from that, a big part of what we focused on is again observability, but also along with that is evaluation, right? And so and that's kind of a that is I mean, this whole landscape is still evolving, but that's kind of probably the more challenging aspect. It's like, okay, how do create an evaluation pipeline that
Hmm.
allows you to, and it's got to be, a pipeline that's reproducible,
Hmm.
and kind of to some degree deterministic, which goes against the whole concept of agents. But
Hmm.
how do you ensure that you're what's Enrique alluded to, versioning our data set? How are you building in a system, like LLM as a judge to be able to uh, evaluate other systems on the platform? How are you
Hmm.
scoring and tracking its performance? And so we're in the process of really developing an evaluation harness
Hmm.
uh, to kind of manage that portion of it.
Hmm.
And so, aside from those things, like I mentioned before, it's the other pieces, reliability, scalability. What do we do in, edge cases when, the person that the agent's talking to says something completely random? How do you put boundaries on this
Hmm.
and handle those edge cases?
Absolutely. I think what's really interesting is at the core, as you start to map out your problem and work backwards to build it up with those microservices you mentioned, it's not unlike any, problem you would have tackled 5, 10 years ago in engineering, right? You have to define your problems, whether that's through a PRD or you're doing some spec-driven development. And through that, you are then identifying the most suitable solutions and how they work together. Now, just increasingly, we're automating how those solutions are interacting with each other and making sure that we can manage them reliably, right? Some of the challenges that I see a lot in those systems are, you mentioned AGI, and we could debate for a few hours here about, whether it's coming next week or in 10 years or what have you. But being able to manage the state for long-running conversations and being able to act upon that, as well as debugging an agent's reasoning. Can you tell me or talk to me a little bit about, how that influences your work that you're doing and how you are continuously improving or making sure a solution is functioning as it should over time with constraints like context and non-deterministic responses.
Yeah, I mean, honestly, this gets back to the basics just in terms of having close communication with our customers.
Hmm.
I mean, they're the ones that are actually using the product. And so um, that's probably more important than ever is understanding, okay, is their experience with it, making sure that we're, using the product ourselves,
Hmm.
uh, monitoring tools. I mean, the Lang Smith platform. And
Hmm.
we actually use Lang Fuse as well. That is absolutely crucial for being able to dive deep into kind of the flow and execution of an agent.
Hmm.
And so, yeah, when it comes to like what are the steps to improve it, that's kind of first and foremost. We've got to constantly be checking in with our customers, and we've got to constantly be checking, okay, this was the input, this is the output. We've got an evaluation harness, which is used as an LLM as a judge, so seeing if
Hmm.
these steps are changing. And then the other portion that we're building in is actually a feedback mechanism, right? Which is, if someone gives, not just gives, it tells us directly, negative feedback, but if they give the agent negative feedback, that goes into our system and get stored, and it's actually later used to modify existing prompts that we have within the system, and that has to tie into the versioning schema as well. And that is absolutely a work in progress because I think all of this
Yeah.
stuff is like kind of cutting edge stuff. But yeah, that's kind of how we move forward with
Super
our
interesting. So
approach.
dynamic context management via customer feedback, and at the root of it, it's still listening to your customers and solving those problems, right? Really defining the problem that you have. Well, AI is evolving a lot. That's still the way that we build as engineers, right? And I think you see a lot of hype in the marketplace around all these AI solutions popping up, all these new startups and so forth. 90 to 95% might be failing. I think a lot of that is I have AI and I'm looking for a problem to solve, and you all are doing it right in that they're listening to your customers and solving problems for them with your AI expertise, right? And when you stay true to that and you look for ways that you can leverage the skills and the expertise you have to solve problems more quickly with AI, that's where you get those great success stories. Um, Henrique, in the coursework you authored for Agentic AI, you also focus on multi-agent collaboration. We heard a little bit about that from Gerald, and advanced LangGraph. In your day job, from what you can tell us, can you tell us about AI ops and productionalizing, and where do those two worlds meet? So how does a framework like LangGraph help you solve the enterprise problems of reliability, governance at scale, and which ones a simple script just can't handle?
Good question. But first, I couldn't agree more with Gerald, like what he said, and it I think it integrates really well with your question, because in enterprise, the challenge is almost never the model itself. Like it's everything around it. Is what Gerald was saying. It's something that we need to differentiate. Like building the agent is not a problem. We have LangGraph. We have like I can dig into LangGraph, but you can use any other, like even LangChain or Pydantic AI or Crew AI, AutoGen. You have like plenty of different ways to build agents, but creating your guardrails, for example, like input guardrails and output guardrails, and making sure that before you move to production, or if you already have an agent in production, you need to evaluate it before like changing a prompt or adding a new node. It's crucial. And Jared said something that's super important. There is the product analytics or product feedback, this feedback loop after
Mm-hmm.
thumbs down and thumbs up from the customers, and how you integrate this into your agentic system.
Mm-hmm.
And this is important because this is part of a story. You first define the limitations of your agent, then you evaluate this, and then once this in production, like post deployment, how you make sure that it continues working.
Mm-hmm.
Coming from MLOps like culture, what Jared said, like made me really happy. And but about LangGraph itself, how it helps everything like this is, I think in the beginning, Jared alluded about creating state management.
Mm-hmm.
And this is a really good part of using LangGraph. You can define your state, the transitions, and it allows to do loop. And everything like this, you can like reprocess. You can like observe everything that the agent or the multi-agent are doing. And if you use tools like the ones Jared mentioned, LangGraph, Langsmith, and LangFuse. I don't normally use LangSmith, but LangFuse is amazing.
Mm-hmm.
LangFuse with MLflow are two great tools for what we do in terms of evaluation and observability, tracing the each action from agent, and
Mm-hmm.
also LangGraph. It's so good to integrate with memory. Not only short-term memory, I mean the session, but also long-term memory, how we can retrieve past interactions, like fragments of memory, so you can customize the experience. So this is super good. And when you're talking about like low latency, SLA, and multi-steps, I want a kind of framework that is lightweight. And I don't want like to install everything from LangChain, like super heavy. I want
Mm-hmm.
something that allows me to get reproducibility. Like you can test your workflow in the graph, and you can debug it, so you can really see in the node what it's doing. Is using frameworks like I know Crew AI. They do a lot. So there are many things happening, and you can see the specific steps. So I really like using LangGraph, and this is the choice in our org. And what my team is doing is making this even simpler to create a graph and make this to production. So that's
Mm-hmm.
kind of what we are doing right now with LangGraph.
So that lower level abstraction gives you increased observability, and that gives confidence in moving those into those higher risk production scenarios.
Yeah, yeah.
Fantastic. Staying with you on this, and without telling us what your stack is at the enterprise, how important is it to have cloud specific expertise for an ML engineer today? Should we be, we're going to interview at company X, go figure out what cloud they're on, or what their architecture is, and how transferable are those skills for AI engineers?
Interesting, interesting. I've been working with cloud providers like for so long, and I'd say that, cloud fluency is even more important than mastery because,
Mm-hmm.
as you said, it's transferable, the skills. Something that you learn in AWS, you have the same offerings in GCP with another brand, with another name. Like, oh, if you're using like Lambda, you have something like Cloud Functions in GCP, or you have like something serverless on Azure. So I think you need to have this fluency to understand what the offerings are doing, so you can,
Mm-hmm.
oh, okay, so let me check in. And there are these diagrams where you can compare, like, okay, so you're coming from blob storage, you have like S3 here, or cloud object, cloud something in GCP,
Mm-hmm.
so it's not that hard. You need to maybe see one video or two, or maybe reading the documentation, and you're all set. But the thing is, when you're in this enterprise scale,
Mm-hmm.
you're dealing with distributed data,
Mm-hmm.
restricted access, cost management, GPUs. Because what we do is, you can of course like subscribe to a I don't know, LLM provider. But if you're
Mm-hmm.
doing this or on prem, or maybe in a cloud, for example, Bedrock from AWS, you need to make sure that you have like understanding of what you're consuming, because
Mm-hmm.
it's not only about the tokens, but the processing these tokens consume. And if you're doing the serverless, you need to make sure you understand the cost. So this fluency is important in the end of the day. So I am like the identity access control, who can do changes over there.
Mm-hmm.
And yeah, I think I responded to your question, I guess.
Absolutely. I think the core of that story is there's a ton of value in having specialization, and certainly in certifications with specific cloud providers. But to get at what the heart of what you're saying, I think having fluency in one gives you exponentially more capability to learn it on another, and it's certainly not a blocker just because you've learned on one. But I find that uh, working in those low abstraction environments, building with Pydantic, working on open source tools gives you the foundation. You sort of see under the hood. And so then when you go to deploy, or you need to go adapt to whatever enterprise solution your company has
Yes.
adopted, you have a leg up there, right?
Yes, and
Um,
just to like add to what you said, one of the things that we started like 5 years ago with all of our data scientists is
mhm,
training them on containerization. So
mhm,
normally data science work with Jupyter or SQL, Python, R. What we did is, everyone here needs to know how to ship models to production. So you need to be comfortable with containers, because if you have like your environment this way, in the cloud or in production, you can have like reproducibility of your work. So that's one of the part, like, okay, cloud, but you need to have this consistency.
mhm. Fantastic. So I've got one more question for you all, and then we're going to shift over to Q&A. So we've talked through the core of agentic systems, the foundations of your roles. Gerald, you're building autonomous agentic systems. Enrique, you're making them robust and scalable in the enterprise. And the audience now is probably thinking, I get it. I want to do it. How do I do it? And Gerald, that was your exact journey from backend, right? What was that aha moment when you realized your engineering skills were a massive advantage for building AI, and not a liability to it?
Yeah. Well, I think the my engineering skills have helped in a couple ways. One is when it comes to working with coding tools, so like Claude Code, and then the other one is an understanding of what I'm actually trying to create. And so In terms of like working with coding agents, as I mentioned earlier, it kind of turns out like the best way and most effective way to use them is by following just best practices of software engineering. So create a plan, right? Which is something even like before agents came along, a lot of people had a hard time doing that. Like people hate, and myself included, people hate documenting things.
Hmm.
But agents are most effective when you can give them a clear specification and examples or an established pattern. And so creating a plan, writing code in a modular way, like separation of concerns, creating small atomic commits, like understanding your dependencies, writing with like testability in mind. These are
Hmm.
all things that when you're working with a coding agent, if you give it those types of instructions and direct
Hmm.
it like your code, you will save so much time, you will save so much hassle and not have to go
Hmm.
back and fix things. There's this term that like I've been coining it myself because I haven't heard it out there. This term, agentic debt, right? We've all known about like technical debt, right? But like this agentic debt is something I feel like I haven't heard addressed. It's like where you just keep on piling on and on, and something that you really don't understand. You're just having the agent build it and build it and build it, and it not only does it create debt for you, it's for your whole team, and yeah, it's just a nightmare. Um, and so, yeah, keeping to the fundamentals with just the development process. But then also, as I mentioned, just understanding, working within existing patterns, right? Like even within the platforms, understanding, like you guys talked about, and Ricky talked about, the value of just, understanding kind of the basic components and services of a platform and how that's transferable.
Hmm.
It's the same here. And I think what's even equally important is understanding what, when you're building on a platform, what are the services or pieces that maybe lock you in. We talk vendor lock, right? Like
Hmm.
what are the things, because you ideally you want to be able to write, somewhere, and if you need to, change the platform, pick that thing up and deploy it. It's never that simple, but
Hmm.
that's ideally what you want to work towards. And that's the same thing with agents. Like you don't want to, maybe even more so because this landscape is still evolving. You kind of don't know the needs that you're going to have in the future. And so you should develop with that in mind. Don't develop in a way that locks you into a specific platform or service because you want to maintain flexibility. And so yeah, all those kind of skills have kind of helped me along the way.
Yeah, I think it requires being a thoughtful architect, right? And so
Mhm.
with that, I'm going to transition and I want to let everyone here know how we can help you architect your own career evolution. So we've structured our entire AI school at Udacity around the skills first philosophy, and we've built it with experts like Gerald and Henrique here. We backward engineered these roles to help you build a portfolio that we just talked about with real world hands on projects that prove that you can build production ready systems. So for everyone attending today, we're offering a 48% discount on our nano degree programs. It's a perfect way to get hands-on with our AI engineer and ML engineer programs and our Agentic AI engineer with LangChain and LangGraph program with these two fantastic authors, and our brand new and upcoming generative AI nano degree, which is all about taking these ideas and making them production ready. We'll drop the link for those in the chat. Uh, Many of our AI programs are now also backed by our partnership with Wolf University, which means you can earn ECTS credits towards a master's degree in AI from Udacity Institute of AI and Technology. So it's an opportunity to get university accredited credentials for your new skills. Okay, so now let's get to the questions that you've all been waiting for. Let's start with how to be ahead in a field that's ever evolving. Gerald, you just touched on this. The requirements are ever evolving. You don't want to get into vendor lock. How do you stay ahead? What do you do to stay on top of it?
Yeah. So honestly, every morning, one of the first things I subscribe to a lot of publications, probably too many. I don't know how many subscriptions I have. It's terrible, but every morning I kind of start off reading. So I subscribe to like TLDR,
Mm-hmm.
uh, which always has like nice technical pieces, and so I subscribe to like the AI publication for that.
Mm-hmm.
There's another publication, Journal Club, which they take complex like peer reviewed articles and break them down into terms that are easy to understand. And I'm not associated with any of those, but my point is saying that it's like, find something that, provides you with
Yeah.
information, up to date news on the industry, and kind of stick with that. And then also identify, and this is really not unique to AI engineering. Identify like the way that you learn.
Hmm.
What are the sources that you kind of look to that can break things down in a way that's easy for you to understand. We've got Notebook LM right now, which is
Hmm.
fantastic. I use that like all the time, uh, and that's kind of how I stay up to date on it. And then of course we've got the Udacity, which Udacity. I started out as a self-taught engineer, transitioned into this industry.
Hmm.
Udacity was the very first um, online course I ever took. Actually, it was a Python engineering course, but um, so yeah, identify the sources. There are tons of consultants on AI or on LinkedIn that are great to follow. I follow pages on X, which are always like discussing articles, and so that's yeah, just find those people and those publications out there and continue to read
I love that trajectory. The student has become the teacher. Look at you now.
them. Yeah.
Henrique, as a professor yourself, what are your thoughts on how to stay ahead in the field and sort of those minimum coding knowledge that's required for an AIML engineer?
Great, great. Um, you know, I need to stay ahead of the news because people keep me asking things, but
Hmm.
it's energy draining, like being like connected to every newsletter available, just like Jared said. But for me, I want to stay ahead of the fundamentals, if you will,
Hmm.
because I try to group all these ideas like, oh, now we have Kimi K2. This is the new models. Okay,
Hmm.
so I don't want to read the paper right now. Let
Hmm.
me just park this for a bit because I know Twitter or X and LinkedIn. If you're in those social networks, people
Hmm.
keep posting every single day something new happens, and
Hmm.
so agent architecture it changed a
Hmm.
lot. APIs change, models evolve like every few months. You have like a new, like, hey, this is wild. We have this model that better than GPT-5. So every
Hmm.
day that happens, But the underlying principles of like distributed systems, observability, everything that we talked today, like
Hmm.
evaluation, data quality. So my main books are about those. So I like to read books, and then one of the things that I really like to do is going to Amazon, for example.
Hmm.
I take the preview book and
Hmm.
I read the index, the summary, and
Hmm.
at least the first chapter, just
Hmm.
to understand and create like a mental map of what is happening, solid, because
Hmm.
these new ideas or stories that we see on LinkedIn and X,
Hmm.
I don't know if they're already like tested, the time tested yet. So
Right.
the foundations they are. If you have a concept like back propagation for so many years, probably they'll continue. So
Yep.
that's my sort of philosophy here. If something has been like for so many time for so long, probably they will continue. So that's what I would try to do and learn the pattern, build real things with what I learn, and like invest in lifelong fundamentals. That's sort of what I do.
Yeah, it can
And
be
I
so hard to wade through some of the hype, right? You see new things coming every day. My own personal experience, I took the summer off. We welcomed our second son over the summer, so I was on some paternity leave. And I came back and I went, oh my God, I'm 5 years behind. It's only been a few months. Like, how am I going to catch up on all the news? And then you start to understand, like, there's a lot of marketing hype and spin out there. There's a lot of, things that are not going to have staying power and what really is going to stick in the market. And then there's things that are completely transformational, like MCP becoming a broad standard that you need to get up to speed on. You mentioned Henrique building. I think that's a core of it as well, right? Not just AI for AI's sake, but having a problem and solving the problem leads you to a lot of those solutions. If it's useful to you, you're going to be seeking it out and you'll learn more about it
Exactly.
rather than just letting it wash over you, which can be super overwhelming. Uh, use the
And
tools, get hands on, build projects. And when you get stuck, seek out those new solutions and you'll probably find some really cool stuff along the
and
way.
use LLMs for that. If you're
Yes.
stuck,
Exactly.
like, you use your favorite LLM pet to
Hmm.
work with you, and that's it. You need to build stuff. So you
Yeah.
get your hands dirty, and you really grasp and master that concept. So if you
Yeah.
just read and even the only the header of the news, you're super you're not deep into the details. Only the surface. I don't know if you'd be a better engineer only reading and reading.
Hmm.
And
So,
I just want to
go
piggyback
ahead.
off of just 2 points both of you guys made, which are really good. Um, so absolutely, like and I want to make sure I clarify that. So uh, what you said is true. Reader will absolutely not get you there, purely that. And so I think what is key is to take abstractions from that. So, for example, this time last year, maybe just a little bit before, if you were keeping up with all those publications, what you would have started to see is there was a trending topic of MCP servers starting to take off, and then that is
Mhm.
kind of like a key. It's like, okay, maybe this is a technology I need to go ahead and learn. And if you kind of stay in touch that this is really unique because we're at a point where it's like if you kind of stay up on that, you can kind of see the trajectory of the industry,
Mhm.
well in advance, kind of before we going to get to that point. Some
Mhm.
of the shifts are kind of obvious. And then the other point I just wanted to hit on is the importance of like doing as opposed to just reading. So as I mentioned, I'm self-taught, and I got into this industry because I wanted to build like an automated football throwing machine. And through that process, I like kind of learned programming. And I have found that, and I started a YouTube channel a few years back during COVID. And that YouTube channel, even though I haven't posted in a while, that thing is the thing that it's kind of the gift that keeps on giving because
Mhm.
employers have continued to reach out to me. And more so than any specific type of project, focus on a project that shows you are willing to learn, right? Like
Mhm.
it doesn't matter really what you build, but if you prove that, oh, I am consistently learning, I'm dedicated to that discipline, employers will seek you out.
That brings up a really good point. I've got one last twofer question for the both of you. So we talked a lot about the different technical skills that maybe people should have, but Gerald, you just hit on soft skills, showing that curiosity, the desire to invent, the desire to learn on your feet. What are the top soft skills you think companies are looking for when they're hiring AI and ML engineers? And we talked about not just learning, but doing as a function of gaining that experience. What's the best first project for someone starting out in AI engineering?
Yeah, so um, the whatever interests you, because that's like the thing that like if you're getting into AI engineering because you just like the name of it, right? And you don't really, it doesn't really appeal to you, you're probably not going to stick with it. And that probably goes for most of it. Like you shouldn't seek out anything that you really aren't that interested in pursuing, even if,
Mhm.
it sounds good, even if the money's good, because that's once you get into you're not going to really enjoy it. And so find a project or an area of AI engineering that truly interests you, and that's going to give you the passion and drive to stick with that and continue to learn. Um, and
And
so,
I
yeah,
think that if I can, I think that connective tissue, whether you're a software engineer or an AI engineer, is that
mhm,
problem solving, right? Debugging problems, getting to the root of it, using the tools you have to solve, uh, is what a lot of people are passionate about. So,
yeah, absolutely, yeah, that stick to itiveness, for sure, that's a factor. I think the ability to challenge assumptions is one, right? And I
mhm,
really want to emphasize that, like, it's not always about knowing everything before you get in the job. In fact,
mhm,
sometimes the people that I've worked with that maybe came in knowing a lot about, sometimes are some of the most challenging people to work with because they have a preconceived notion that it's a one size fits all solution, and that's never the case in engineering. And so, yeah, flexibility, and I cannot emphasize enough, like desire, proven desire to learn. And so you should be thinking
mhm,
about, how can I show somebody that, like, I've done this, right? And it's harder now because you can have these AI coding agents create this stuff. So maybe you think about, okay, maybe I'm going to create a publication, or I'm going to put myself on video of me explaining technical concepts,
mhm.
which proves that this is a path I'm interested in.
There's never been a better day to start, right? The democratization is real. And we are coming up on the hour. I want to thank both of you for spending the hour with us, as well as all of the audience at home. On our way out, Henrique, if you can give us very quickly, best first project for someone starting in engineering. I won't hold it against you if you hawk your own Udacity project either, but no pressure.
Yeah, we have so many good projects starting here in Udacity. So creating an agent from scratch using LangGraph. You grasp these ideas like, okay, so I have the nodes, I can connect it, I can call a tool, it's a loop. So starting here does, you're really building something. I design what 2 or 3 final projects, like medical ones. We have like the one with electrical engineering. There is my field. So we have good projects over here, so you can have your hands dirty.
Fantastic. That's a great place to start. Thank you both again, and thanks for everyone for tuning in with us. We'll see you on the next one.
Thank you.